25,000 volts AC single phase. Now, such a high voltage will not work for the AC traction motors that are present in the locomotive. The function of the transformer is to transform this 25,000 volts AC single phase current into an operable voltage range of around 3000 volts AC suitable for the traction motors. Next in line are the rectifier units. The function of the rectifier is to transform AC voltage into direct voltage. Here we can see the sinusoidal waveform of alternating current, which is present in the overhead equipment catenary system. We will see how the rectifier rectifies this alternating current into direct current waveform. However, we can see there is some residual alternating form left in the waveform, which is not suitable for a pure DC output. To solve this problem, in order to get a smooth DC output, we need something called the inverter. Between the rectifier and the inverter units, there is something called the DC link, which includes the filter circuits, which we will discuss later on. A constant pure DC voltage is obtained using the filter circuits from the residual AC form waveform produced by the rectifier. The filter circuits are nothing but a combination of inductance and capacitance circuits, which are very useful in converting the waveform into a pure and constant DC voltage. The inverter output of three-phase AC voltage is fed via the axle brushes returned to the track in order to complete the circuit, and also to the traction motors. Three-phase AC current ranging from 1500 volts to 3000 volts AC. The traction motors are asynchronous three-phase 3000 volts AC electric motors for smooth operations. They are controlled by tap changers or various other modern equipments in order to change the voltage. The inverter converts single-phase DC output from the filters into three-phase AC for the requirement of the traction motors. These are the batteries. They help in providing the starting current and for electrical transients. Battery isolation switch. Transformer. The transformer converts 25,000 volts AC into 3000 volts AC current. Fire handle. Air compressor. Air compressor compresses air to be used for braking, to fill the brake reservoirs, and to raise and lower the pantographs. The transformer is filled with oil which acts as a lubricant and to dissipate heat. The red port is the oil fill and drain used during maintenance. Sanding box consists of sand. This is used during wet season to increase the adhesive force with the tracks. The UIC control jumper cable helps to transmit the control signals of the master locomotive to the slave locomotives when consisting is done. The jumper socket is used to extend the UIC control cable connection across several locomotives. The Class 92 is equipped with twin pipe air brake system. The twin pipe plumbing runs across the train from the locomotive to the last coach. This system has several advantages over the single air pipe brake system. The main advantage is the brake release times are way faster than the single pipe brake system, and they are more robust in design. In case there is a leakage or a break in the pipe in one of the wagons or the coaches, the train can be carried across in a single pipe mode by bypassing the coach. The red pipe is the train brake pipe, and the yellow is the main reservoir brake pipe, as discussed previously. ETH, or electric train heating, is similar to head-on generation, where the locomotive supplies electricity to run electric train heating and other auxiliary functions. The ETH jumper socket is used to extend the ETH connection across several locomotives. The pantograph is a component of an electric locomotive that collects the electricity from the overhead contact wire and passes it on to the transformer in order to run the traction motors. The collector head helps to collect the electricity from the overhead contact wire in the overhead equipment and transmit it to the locomotive's transformer via the insulators. The upper arm is a supporting structure of the pantograph. The lower arm, along with the raise bar, helps in the extension and retraction of the pantograph. The insulators make sure the locomotive body is electrically isolated from the pantograph. This is the pneumatic actuator, which helps in the traction and extension mechanism. I will show you the operation of the pantograph using the Nce Power Cab. I press F27 to raise the rear pantograph. Pressing the option key, I press it again to lower the rear pantograph. Now the front pantograph will be raised using function 26 key. And now you press it again to lower the front pantograph. This is the air conditioning equipment. The grilled area is the evaporator. The vacuum circuit breaker helps protect the electrical circuit. This is the brake resistor. The brake resistor helps dissipate the heat generated during dynamic or regenerative braking. These are the locomotive's cooling grills from the radiator. This is the air conditioning outlet duct through which cool air is introduced into the cabin from the air conditioning unit.